In this lesson, we're going to discuss similarity in measurement. In particular, over the last few lessons, we were looking at similar shapes, trying to identify corresponding sides, corresponding angles, figuring out which pieces match up with each other. Before that, we were focusing on proportions, how to set them up, how to solve them with cross-multiplying or equivalent ratios, etc. Our work today basically combines those two things. We want to set up proportions in the context of similar figures, and then by solving those proportions, we will be able to find an unknown length in a pair of similar figures. Of course, we could do this for word problems, but don't forget this massively important skill of being able to set up a correct proportion. All right, so here's our first piece. Given that this quadrilateral EFGH is similar to quadrilateral ABCD, find the length HE. Well, of course, this entire thing is about setting up a proportion. And in order to set up a proportion, you have to make certain that you're identifying the corresponding pairs of sides. Those corresponding pairs of sides we can use to set up a ratio. All right, so how do we do that then? Well, a lot of times you can just look at them and identify behavior and say, okay, well, that's obviously how it goes together. For instance, when we look at this, we can see in this shape that we've got a short base and a long base. In the other one, we've got a short base and a long base. That type of behavior is what is going to identify the corresponding parts. We should recognize that 30 corresponds with 12 because those are both the shorter bases. We should recognize that x and 16 go together because those are the longer bases. Recognizing those pairs allows us to create the proportion, saying 30 corresponds with 12 and x corresponds with 16. There's our proportion. And we can now solve it. We know that we could cross multiply 12 times x. 30 times 16 gives us 480. And when we divide this one out by 12, 480 divided by 12 gives us a length of 40 inches. There we have our answer. Next problem. For what goes together? When we look at the problem, it seems fairly intuitive that when we're looking at this, we would have the base and the base go together. Visually, we should be able to recognize that. However, we want to make certain that we're not just launching into it and saying, okay, these things obviously go together, because when we're working with it, we want to make certain that the correct pieces go together. And I would like to remind you, our similarity statement has a tremendous amount of power. It tells us all the corresponding sides. When we look at this base of BC, that's in position 2, 3. We know that it has to match up with, likewise, position 2, 3, which is LK. That would allow us to put these pieces together, saying BC is 35, LK is X, and we've built 1/2 of our proportion. Working similarly, over here we'd have length AC. AC is position 1, 3. What does that match up with? What does it correspond to? Of course, 1, 3 corresponds 1, 3. That's going to give us JK. And we can recognize JK being right here, build our proportion, saying 45 and 36. Now, I'm looking out at some of you guys in class and saying, well, obviously, Fry, you got the base goes with the base, the slant goes with the slant, those pieces are easy. And you know, with a lot of problems, it is easy just to look at them. but I want to make certain that we're emphasizing this as a tool because there will be problems that are more difficult to set up. And with problems that are harder to visually see what goes together, this technique can help you build your proportions when you're working with a more difficult problem. For simpler ones like this, we can build it, cross multiply, and get our answer. So 45 times x, 45x. 35 times 36, that's 1,260. And when we divide out by this 45, 1,260 divided by 45 gives us 48. 28, not 48, 28. And so there we go. We've got our length, 28 millimeters. And we're done. All right, for all you Breaking Bad fans out there, Walter White likes to hang out in the desert for, unknown reasons. Some more information, Walter White is 6 feet tall. And when he's standing out there, he's got a 2-foot shadow. Well, at the same time, a Saguaro cactus has a 5-foot shadow. How tall is the cactus? Remember, when you're working with these pieces, the key characteristics, you can always set up a proportion. When you're working on setting up a proportion, you have to make certain that you're paying attention to the labels. We can look at this one and say, we've got height and shadow are the two things that we're working with. If you're not certain how to set up a proportion, pay attention to the labels. They tell you exactly how everything can be built. For the cactus, height and shadow. H feet, 5 for the shadow. For the person, 6 foot, 2-foot shadow. Tells you exactly where all the numbers will wind up going, so we can build our proportion, h over 5 equals 6 over 2. Solve it any way you'd like. For this particular one, I would look at it and say 6 over 2, that's just 3. And if I multiply by 5, I can cancel out that division and get my answer that way. We've got 15 feet tall. Of course, there are other ways of solving it. The primary characteristic here is that you set up a proportion to match the corresponding pieces. What about here? Our last example for the video. Triangle ABC is similar to triangle DEC. Find BE. Well, admittedly, this is kind of a tricky one because when you look at the problem, what a lot of students are going to look at and say, okay, well, we've got this base and it has to match the base. So they're going to say 20 matches 15. And then they'll look at it and say, okay, side length and side length. So they'll build a proportion, 20x and 36, just using all the things that you see. It's very common for students to look at the proportion and build this, and it's wrong. So what's wrong with that? The important characteristic, of course, and this is where I'm going to go back and use this piece again to show you why it's true. Oh, that's not what I wanted. Come on. There we go. Slide this over now. When we start building our proportion, we of course have the base AB, which is position 1, 2. We know it has to match up with position 1, 2, which is DE. No problem there. AB has to match up with BE, which was that 20 over 15, exactly as we were saying before. The problem that we're running into then is when we look at this smaller triangle right here, this length of EC for the small triangle, EC is position 2, 3. it corresponds then with position 2, 3, which is length BC, and BC is the entire side. It's not just the X. It's everything all the way across. And so when we set up this proportion, using just X is not including the full length of BC like we're supposed to. Instead, when we look at this full length, you are supposed to recognize that it's the X length and the 36 length combined. That length is X plus 36, not just X by itself. And for a lot of students, when they look at this problem, they don't quickly recognize the fact that they're supposed to use X plus 36 because so many of our earlier problems didn't have that kind of addition. But with some of our homework that we had, we did have problems that looked like these. And we saw how we could solve them. It was still based on cross multiplying. But when we multiplied, we'd have 15 times X plus 36, making certain to keep our parentheses there. 20 times 36 would equal 720. And so we saw that we could build an equation. With our work then, we saw that probably the easiest way to solve this is to divide out by 15. And that would give us X plus 36 equals 48. All right, and so to finish solving it, we know that we could subtract off that 36, giving us a length of 12. And since BE is that length of X, we've got our answer that we're looking for. It's 12 inches long. And that finishes us up. We finished at we looked at each of the 4 different examples. Remember the key characteristics. If you do not set up a correct proportion, if you were to somehow miss some relevant information and set up a wrong proportion, even if it's mostly correct and has a lot of good stuff where it's supposed to be, if you make a mistake with setting it up, it doesn't really matter what you're doing afterwards because garbage in is going to lead to garbage out. That's why it's so important to set up our proportions correctly. Whether it's a word problem where we need to set up the proportion, it's a simple picture, it's a complex picture, we know that we can use proportions to find those lengths within a set of similar figures.